To formally welcome the gathering, I would like to invite the President of the SLIA, Architect Rohana Bandara Herat, to the podium.
Very good evening to you all. Distinguished invitees, my dear council colleagues, dear past presidents, colleague architects, sponsors, and staff of SLIA. It gives me a great pleasure and privilege to welcome you in this very important evening. So we have come to our second CPD event in this year. The topic, know your material and products. We all know that CPD is a compulsory requirement to upgrade, to top up, to sharpen our knowledge as professionals. But today, our CPD committee has invited two eminent speakers to speak to you and to educate you all on two areas. One is aluminium, the other areas is paint, coating. I would like to welcome on behalf of the council as well as on behalf of the Professional Affairs Board and the CPD committee. The first speaker, Mr. Dilshan Fernando, the well-known figure in the industry, an expert of aluminium especially. Our second speaker, Mr. Gerald De Seram, again a well-known personality, a well-known person in the construction industry. Let me welcome our young, energetic CPD committee, chaired by Architect Dani Rajapaksha, as well as Professional Affairs Board Chairman, Architect, our colleague Mudita Premathilaka and his team. Today, we have invited two past presidents who will serve here as the moderator as well as the panelist. Both are from the same region in Sri Lanka. I would like to welcome both of you for this CPD event. And also, without our colleague architects, we cannot make this kind of events a great success. I would like to welcome our colleague architects for this CPD event. We must not forget our sponsors, Sleep Masters Private Limited. So you could see their products which are displayed here. During the fellowship, you can experience. So I must welcome very warmly our sponsors today on behalf of the council as well as the SLIA. We must not forget our caterers and other colleagues who help us in many ways in organizing this CPD event. Finally, I would like to welcome our young compeer, architect Dulux Rajendra. Once again, I would like to welcome all of you to this CPD event. Thank you.
Thank you, Architect Rohanabanda Arherat, for that warm and heartfelt welcome. Now, I would like to invite the chairman of the PAB, Architect Mudita Prematilaka, to the podium to speak a few words. Please welcome Architect Mudita Prematilaka.
President, Council, dear colleagues, and our special guests, thank you very much for coming today. Today we have a very special. Program. We figured out from the PAB. We figured out that we need to go more into details of specifics rather than talking these broader topics in general, which we always do. So that's why we introduced this special program. Know your materials, know your products. After this program, you will realize how much we don't know really on these two, though they are just two words. And my sincere request to all of you all to maybe take your notebooks out, maybe some tips I'm sure you will have to write down. It will help you in your profession. All the best, and I must thank my committee, Board of Professional Affairs Board, and the CPD Chair, Dani, and the team, and my managers. Thank you very much. Enjoy the evening.
Before we move on to the proceedings, there is a presentation. And for this, I would like to humbly call upon Mr. Rodney Senanayaka, the CEO of Sleep Makers Private Limited, who is our sponsors of today's event, to address the gathering.
Good evening, ladies and gentlemen. First of all, I take this opportunity to thank the association giving this opportunity to sponsor this event. I'm very confident this marriage is going to be very fruitful and bear fruits. Because we have our target group and target groups for our specific products. And all those target groups are 90% is handled by you gentlemen, the architects, from the grassroots level to the finer point. Your word of mouth can kill whatever the marketing communications that we do. Your word of mouth is very powerful. And also, I would like to say, Sri Lanka, don't misunderstand for saying this, is a bit corrupted, but this association, architects, are not corrupted. All the other associations that we have worked, they will ask something. So I salute everybody here for the wonderful job that you all are doing to promote this industry. Thank you very much once again. Now, before I start talking about the bedding industry, I would like to share my experience. I have worked for 2 leading brands in the world as CEO, and I was overlooking 11 countries. Now I'm just nearing my 75th year. Still I'm working because I'm sleeping on a good mattress. That is Valentino branded, right? So I want you all to change. If you are not using Valentino branded mattresses, I humbly request you to replace immediately and you can maintain my figure. Right? I have my MBA. That is not for anything. Married but available. I was just joking. So sorry for saying this. Now, before I start talking about the bedding industry, I would like to talk to you about the sleeping habits. You must understand, now I'm 75 years old almost. I have spent 1/3 of my life on the bed, sleeping or just looking upstairs or something. So you have a balanced 2/3 totally depending on the mattress that you sleep. You've got to be really careful about the structure. Today you can see most of the people, they call us, they want a good orthopedic mattress. Why? The mattress is saggy. So you've got to be very, very careful. When it comes to our mattresses, I will elaborate differently. How we do our mattresses is we have support, comfort, durability, uninterrupted sleep, and health connection. Give me a few minutes to support. You need the proper support to your spine. If you don't get that proper support to your spine, you will definitely feel the mattress is uncomfortable. Second thing is comfort. Comfort is not a thing, it's hard or soft. That is individual preferences. Comfort of a mattress is how fast the mattress can adjust according to demands of your body. You take husband and wife, lightweight, heavyweight. Same mattress must provide the best. My wife is a heavyweight, but she doesn't grumble. Right? So I'm just telling you all to, if you're not using our brand name, immediately to change. Right. So the third thing is support comfort. Durability. Very important when you buy a mattress, durability. That is, you got to enjoy the factory freshness. For that, we are giving you care tips. Fourth important point is the uninterrupted sleep. For at least for 5 hours, you got to have uninterrupted sleep. That is the time that the body starts repairing. Carbohydrates will be burnt. Pressure will come down to your normal level. Skin is bright. Eyes are bright. All those things will be provided in a good mattress. For comfort, durability, uninterrupted sleep. Health connection, very important. You will lead a good life. Well-being, you will keep your doctor at arm's length. Now I will come to the other brands that is available in the marketplace. Don't misunderstand for saying this. I'm only going to differentiate. There are good brands in the marketplace in Sri Lanka, but all those brands are providing the comfort. They say, okay, it's a very comfortable mattress. This is pillow top. This is Euro top. If you go for 12 inches one, it's much better. You will have extra comfort. It is true. That is how even we, or in the past, everybody marketed in that fashion. Today, it's not that. Today, people are health conscious. Why? They don't take their meals on time. We take that. By nature, we have got breakfast, lunch, and dinner. Those are planned meals when we were young. Today, fast food. The fourth meal is the sleep. People don't know this and don't misunderstand for saying this. So now, if you see the other brands that are available in the marketplace, I have worked for 2 best brands in the world. They say, this is the product that you got to sell because our margins are high. I'm telling you the truth. I'm not going to run down anybody. But in our case, it's not that. I will come into that. So I want to differentiate ourselves from the rest of the pack. They have mattresses 10 inches, 12 inches. Then they will say this is pocketed spring, bonal spring. No doubt, maybe brands are good, comfort levels are good. But there is no any health benefit from those mattresses. Don't misunderstand. Please don't misunderstand. I'm not here to run down. If I lose my job here, I must get into a competitor again. So because of that, I'm not going to run down. Right. When you take our brand, the Valentino brand coming from Italy, our principles are boy tech. We have got the exclusive rights. The Valentino brand had taken another extra step called extended life collection. Extended life. Anybody wants to take that extra mile in life. So we are providing that. Because most of the mattresses trying to do, they want a mattress. Then they will sell that, wants. But here, it's not like that. We have 6 varieties of mattresses under Valentino brand for extended life, and also we have 3 other brands, 3 other products for the hotels and the personal life. So we want you all to come to us, and we will go into details to identify the need. Sometimes the most experienced person the most richest person will walk into our place. That doesn't mean that we should sell the most expensive one to them. Our people won't do that. They go into details, look for need, and specifically we sell that particular product. So we have 6 varieties of mattresses for that purposes. Are you clear with what I said? Okay, we have different. So extended life, we have 6 varieties. Now I will talk product by product. Now, okay. Out of 6 matrices, we have 2 matrices which provide therapies. Right, this particular matrix will provide therapy that's called, give me a minute because I just came from Australia. Right. This is vibrational therapy to improve your good energy flow in the body. Right? This will help you for that purpose. Very clever. Magnetic stress. Magnetic stress is a magnetic therapy for iron deficiency. For iron deficiency and the rest of the other things. So we have 2 matrices with therapies. The other 4 will provide antiseptic technology for stress and for that. Okay, the other one? I'm sorry. This is the cooler matrix, a permanent feature. You can use
or documented specifications, maybe hearsay, maybe you have had a good past experience with that product, or maybe your client prefers it, maybe you prefer it. Maybe it's just that your salesperson from the supplier has given you a great pep talk and convincing you that it is the best product for you. In a context like this, we thought that we should know more about the materials for to going forward. So in this segment, we are actually trying to provide you with additional information, in-depth information, lesser-known information, different aspects of the commonly used materials in the market and in the industry and in practice, which could be very crucial sometimes for the functionality of your building, your aesthetics of the building, client satisfaction, safety. Sometimes it might even come down to your own reputation as an architect. So today we are doing this under this theme of know your materials and products. We are hoping to have a few segments like PAB Chairman Mudita pointed out earlier. We are planning to have at least one or maybe two a year, CPD events a year with this, under this umbrella theme, know your materials. So today we have, this is sort of a pilot segment today, and of course you being the guinea pigs, but we do have fellowship at the end of this. So dinner, music and drinks going to be okay. And also we have two experts in the industry with huge, tons of experience behind them, talking to us about two materials, actually one material, one product, which we have chosen to discuss for today. Mr. Dilshan, and to top it all, we also have two of our eminent architects as moderator and panelist. So Mr. Dilshan Fernando is going to talk to us about performance and safety of aluminium windows in mid-rise and high-rise buildings. And Mr. Gerald De Seram is going to talk to us about performance coatings, architectural coatings, performance in architectural coatings, right? Right. So having said that, again, the topics of the speaker, the specific topics of the speakers may seem very limited, but you are very welcome to ask questions, general questions in the Q&A sessions, discuss related matters. I'm pretty sure that we are going to have a very interactive Q&A session, and I will let Vilakshi introduce you to the speakers and the panelists. And I think I should stop babbling now and let them get on with it. Thank you very much for being here today. I hope you find this segment useful and that you will have a very interactive and interesting Q&A sessions at the end, and of course fellowship. Enjoy your evening. Thank you.
Thank you, Architect Dani Rajapaksha, for elaborating on what CPD Session 2 is all about. Now, it is time to allow our eminent speakers to address the gathering, lining one of the most interesting and trending themes of all time, I would say, just to get you all hyped up a bit. Know your materials, products, performance and safety aspects of aluminium and paint, and how this can add value to us as architects in the modern changing world. To open the floor, our first speaker for today is a Managing Director of Eurometallic Private Limited, Mr. Dilshan Fernando. Before I hand over the podium to him, I would like to do the honors by introducing him to you. Mr. Dilshan Fernando have been involved in architecture for 45 years, where he started his career at Surat Vikramasinghe Associates as a draftsperson. He worked under architect Jeffrey Bawa in Colombo and architect Chandra Abhisinghe in Singapore before joining Access Group of Companies, where he was assigned to manage Access projects in the 1996. He was also in the inaugural SLIA Part 1 course, and at present, he is an architectural licensee it. With experience gained, he was given the opportunity to head Access Projects Private Limited as a C1 and F1 construction company for the last 30 years. He is fully experienced in timber, aluminium, joinery, and construction detailing, where he was able to construct many award-winning hotel projects. Since 1996, he has been involved in the aluminium door, window, and facade industry and represented a major international brand which has been very successful in Sri Lanka. He was the first to establish a window testing lab in Sri Lanka during COVID-19 and has designed many innovative solutions to the window industry, which is internationally accepted. Mr. Dilshan has categorized himself as a builder and a support to architects in finding construction solutions to building projects, detailing, and with special emphasis in aluminium door and window design and specification. Please welcome Mr. Dilshan Fernando with a round of applause. Over to you.
Thank you for that introduction. Good evening, everybody. And thank you to SLIA for inviting me for this. And my name is Dilshan Fernando. Usually get mixed up with the Fernandos. Okay, so today we are here to discuss aluminium, which is one of my pet subject areas. I come from Moderator, so timber joinery is the other. And in today's discussion, I'd like to impart to all of you some aspects which are not readily discussed or will crop up in your careers, your projects and your documentation. It's a very important area which is often not looked at thoroughly. So moving forward, the discussion topics which I would like to put forward to you all. What is the expected performance and safety of aluminium windows? The expected performance. What is failure associated with windows? What causes a window to fail? And what are the regulations to prevent such occurrences? And what can be done to reduce failure? I'll tackle this one by one. So the expected performance of a window, for all of us, is protection from rain, wind, and other elements, to keep the intended aesthetics, sometimes a safety as a barrier or a physical barrier for people going from one space to the other, and most of all, to keep its value over a long period of time. Somebody asked me, what is the lifespan of an aluminium window? You cannot change windows in a building if it is 10, 15, 20, or 60 floors high. It's not possible. So the aluminium window has to match the lifespan of the building. You cannot, it's not like a curtain that you pull off and put another one. No, it's almost permanent. So we have projects in Sri Lanka. I think the earliest I can remember is the Colombo Hilton, which has aluminium which came from Japan, YKK. And it's only now it's getting replaced for a refurbishment. But not before. There are older buildings. Selinko building would have had, and it got burned down, and they had a new one coming in. So we are rather new in this aluminium use in Sri Lanka. So for all of what that I have put up there, the protection, the elements, etc., a window must stay a window without deterioration and failing in its purpose over its accepted lifetime. By definition of this presentation, by what I mean a window, it could be a door, it's everything aluminium. So to make it easy, I just put windows here. Then I come to this, the audience here. What do clients expect of their consultants? Best advice, be knowledgeable, able to spot a defect, be updated and specify the appropriate window. Each situation will call for a different solution or a different angle of how you look at windows and the material. So this presentation aims to make one aware of the lesser known facts about windows, their performance and safety. There's a whole lot that is known, which I will also brush upon, and there's no need for us to relive that or just go through that. It's all there. The usual specifications in documents relating to aluminium windows, you would probably see it in a document, the BS, British standards, the ASTM, American standards, AS, Australian standards, EN standards for Europe, and they are all towards structural resistance to water penetration, air loss, acoustics, burglar resistance, testing procedures, color coating or anodizing, fabrication, installation. All these are there in specifications. They are there in the BS and it is already in your tender documentation. So the presentation is to make one aware of the lesser known facts of the windows and their performance and safety. It's not that even if you actually go through this whole documentation and enforce it, you may still have failures. And let's look at that. I determine a failure of a window as a window falling off. I don't know how many of you all have heard of windows falling off buildings. It has happened in Sri Lanka. It will happen in the future because our buildings are just going into that era of time. Leaking, that's something that everybody knows. And the solution to a lot of that is actually silicon. So some contractor will come with a bucket of silicon and then he will fix the leak and it will come back the next year and then the year after that and so on and so forth. Deterioration over time. The color that you specify may not be the color that you get in 5 years. It can peel, it can crack, and not perform into expectations. And mind you, the defects liability period is just 12 months. The warranty is usually 10 years. What happens after that? So this is Hong Kong. The first high-rise in Hong Kong is probably around 1935 and then coming up. As you know, Hong Kong is a densely populated area and has more high-rises per square kilometer than any other city. So Hong Kong would have faced, with the typhoons, the windows falling off. And it did happen. Closer, we take Singapore. The first high-rise around 1941. So we are looking at around 70 years of high-rise buildings or mid-rise buildings. Sri Lanka, 1962. Any guesses the famous building, Akasa Kade, 1962. So compared to Hong Kong and Singapore, we are around 30 years after. Okay. Let's look at the buildings that we have now. And mind you, my presentation is not only about high rises, it's about a general window. I'm just emphasizing on this because a window can fall from a high rise and cause great damage. But if a window falls off a single-storied house or a two-storied house, it may not cause damage because it may fall onto your own garden. So you see all these buildings happen now. There's much more than what I show here. So these are examples world over on what happens when windows fall. So this is Hong Kong, UK, Germany, Italy, where people have actually died with a window falling on their head, cutting themselves, and they're dead or maimed for life. So we then ask ourselves, can it happen in Sri Lanka? Remember Sunil's song, Engalante ehema unat Lanka ehema wenne naha. You know, we are such fun-loving people. No, it will happen in Hong Kong, in Germany, it will happen in Singapore, it will not happen in Sri Lanka, but we don't know. Do we? Yes, it happened. It happened in a complex of high-rise buildings in Sri Lanka. I don't want to name the project, but it did happen. And a window fell, squashing a vehicle. And this is actually the latest data from Singapore. 35 cases of fallen windows in the first 11 months of 2023. Okay, this is Singapore. So what action would they take? And why does it happen? In Singapore, it is basically the corrosion and weakening of aluminium rivets. Hey, pop rivets. Very famous in Sri Lanka. It's Kokatat Tailaya. Every aluminium subcontractor will swear by the pop rivet. They use it widely to fix windows. It's a pop rivet. So easy, you just drill, you put some gadget in, plop, and that's done. It's fixed. But it corrodes. And the cases of windows failing is basically through its weakest link. You know how strong a chain is. It's only as strong as its weakest link. Don't forget the space shuttle burst into flames. Not because of any fault of the space shuttle, but just that insulation was not there, a simple piece of insulation. Titanic sank. We've got loads and loads of area where a small thing would have caused a major disaster. So a window will only fail by its weakest position or the weakest point. And what is that? So we go back to Singapore, and it says investigations found that the main reason for casement window panels falling out was corroded and weakened rivets that were unable to hold the panels in place. So everybody knows of casement windows, like the ones that open out like that. Okay. So it has hinges. If the hinges disengage from the frame, they fall. And how many times do our subcontractors use rivets to fix the hinge to the frame? They do it. Or they use a screw, a self-tapping screw, which has going into maybe a 0.7 thickness of aluminium. Is inadequate for high wind. The main cause was a lack, in case of sliding windows, the main cause was the lack of proper safety stoppers and angle strips to keep the sliding windows panels within the track and prevent them from being dislodged. So we all know that how the contractor fixes the sliding window is that they will push it up to a groove or a recess and they will put it down and it will run on tracks. That's how it is. So in those days, we used to have garage doors like that, which ran on wheels. And the rogue used to come and put alavangu and just lift it up and lift it off the track. You can do it. The same thing happens with the sliding windows. Wind can lift up the windows and put it off their track. And it happened. It happened in Sri Lanka. I can now tell you that building. I think that building was previously there was a Sri Lankan Airlines office in Kolpeti. Previously. I know a window fell off that, a sliding window. Many, many years ago. So what happens in Sri Lanka if a window falls? It's a hush-hush affair. Nobody talks about it. No developer will ever put their hand up and say, hey, my windows have fallen. Okay, no one will do it. It's hushed up. The engineers are not informed. The architects are not informed. There is no regulatory body to identify failures and take action to prevent those. So, I'd like to go back. So, we all know that Singapore is a fine city. Now, if your window falls down in Singapore, you can face up to 5,000 Sing dollars in fine and jailed up to 6 months, or both. For lack of maintenance, homeowners can be fined up to $10,000 and jailed for up to 1 year or both. Since 2006, we are now in 24, 406 people have been fined and 94 people have been prosecuted over fallen windows. Okay. That's Singapore. And what do they say? You have to replace all the aluminium rivets of your window with stainless steel. It's a law, it's a regulation. In Hong Kong, it's even stiffer, which I will come to that. So the performances, again, that are covered through the tender documents would be water penetration, air infiltration, structural performance against the given wind loads, acoustic performance, burglar resistance. We all know this. The material specifications for aluminium and gaskets and glass and hardware, we all know this. I don't want to go into that because it's all there. Powder coating or anodizing specifications, it's all there. And the thicknesses, so on and so forth, it's all there in the tender documents. Require proprietary system? Sometimes. Window testing? Yes, sometimes. Experienced contractor? Yes, we call for F1 certification. Structural calculation and engineer certification? Yes, we do that. We all do that. But where is the problem? So if we do all that, then there should not be a problem. But there is a problem. Because there is the weak point in a window, which I will tell you guys all about it. It's in the joinery. Aluminium is not welded together. It's joined piece by piece. The glass is just put inside and some beadings put in place, so it's joined. It's like a whole heap of sticks joined together with glue, but there's no glue. What do we use? The local system, mostly 90% of the local systems that are sold in this country, the contractors will use a small L piece to fix 90 degrees, one aluminium bar to the other. That's exactly how 90% or 99% will do it, because it's the easiest and the most cost effective. The new systems, I think companies like Alumex and Swisstex have introduced. It's a little bit expensive, but they do have what is called the extruded corner pieces, which is there, the extruded corner pieces that go deep into the aluminium member, and it is squeezed shut, which we call crimping, or it is mechanically tightened, but it is not pop riveted. I can assure you, these will not be pop riveted. It's useless to pop rivet these things. You have to go by the specifications and standards given by the company that is the owner of the patent or the design. On the extreme right to you, you have what is called a magic corner, which is a newer system of fixing aluminium together, which is now in the market. It is used by proprietary systems and also other people. It is also a good system. It's a mechanical fixing system. So the two systems that I have given a tick are ones that do not use pop rivets, are the ones that can stay safe. So if you're looking at windows on the quality, you can always ask your fabricator, what is the system you use to join? And if they say we are using pop rivets, you can tell them, okay, fine. You can use a pop rivet, but use a stainless steel pop rivet, not aluminium. So be mindful. The Singapore law says that you have to change from aluminium to stainless steel. It's not a big difference in cost. So some people will come and say, oh, I can't afford to have these systems, they're fancy systems, I can't afford. Yeah, well, it's no problem. Go for the pop rivet, but it has to be stainless steel. So it's one important point that I wish you would take home today. The next is fixing of sashes to frames. So you have a sash, which is probably with a piece of glass, double glazing or any other thing. Now this is hanging off a frame. So how do we fix it? We sometimes use the 4-bar hinge. We all call it the friction stay. We also use the normal hinges, either a stainless steel hinge or an aluminum hinge. But how do you connect that to the frame? And what is the norm or the regulation that exists in Sri Lanka for that? Sad to say, we have not gone to that yet. as having these specifications like what Singapore and Hong Kong have. We have not come to that stage yet. Probably we will, but you all can have your own rating of quality in wherever you specify these things. So the screws have to be used, not rivets. The specification is that you have to use screws, and it must go into 4 millimeters thickness of wall. You can understand that if you use a screw, and if the screw goes into something that is paper thin, we'll say 1 millimeter of aluminium wall, and you know how soft aluminium is. You can actually put something into 1 millimeter of aluminium and pull it out without any problem. Because the thread in your self-tapping screw will only have maybe 1/2 of a turn cut into that. Okay, so it's not a great fixing method. But the specification in Hong Kong says, and which is used widely by European window manufacturers, is that whatever you're fixing, your hinge or your 4-bar stay, which is the friction stay, should go into 4 millimeters of aluminium screwed by an M6. So it's not a self-tapping, it's a proper screw. So 4 millimeters will have so many windings for it to fix onto that. Okay? And of course, if it is possible and if the project can afford to go for tested elements. Your hinges can and they are tested by responsible companies. They will have a testing for 50,000 cycles or 100,000 cycles. You can ask for the test. Your hinges will have a quality certificate issued against corrosion, salt water spray for X number of hours. All these you can ask, do you have this, do you have that, especially if you are doing any project near the ocean. Be careful with the salt. Salt corrodes aluminium, I can assure you that. Aluminium is highly corrosive. It just corrodes. We think that aluminium is not corrosive, but aluminium is corrosive. You get some white stuff, and especially if you have an air-conditioned room, on a hotel room, the weather outside is like 85% or 90% moist with salt sea air, humid air. The moment you open the window, you have a cold aluminium window where this will come and just deposit, and you will have the white stuff depositing and it will cause corrosion. Okay, it's happened to me. I had to replace something like nearly 200 doors in one hotel project because of corrosion and because of ignorance of putting one of the world's best locks, but it was steel, and the steel got meshed with the aluminium, and I had to replace the window because you can't replace the lock. It's all like kind of molded together. So be careful. And it's really impossible to find stainless steel locks in the market. For some of my projects, I actually bring down a lock from, guess what, a cruise ship manufacturer. So I thought that bloody hell, if it go on the seas, it will work. And it worked. So those locks and those are all made out of 100% brass and stainless steel. Right? So they don't deteriorate, and they are actually made for marine conditions. So, but it's difficult to find in the local market, and it's not possible just to import a few because the costs are prohibitive. So be careful when you specify locks and check and select a lock. The front face is stainless steel, and they'll say, okay, this is SS304 or this is SS316, but the inside is all springs which are highly corrosive. It will give way, so be careful. Fixing frames to the structure. Now we are talking about the frame to the structure. We discussed putting the frames together. We discussed a sash fixed onto the frame. Now we are discussing frame to the structure. So there is what is called galvanic corrosion, which is a deterioration of aluminium. The process occurs when dissimilar materials are in contact in the presence of an electrolyte, like salt water. So basically, this is something to do with the periodic table. Those who are clever in chemistry will know more about this. I don't want to pretend to say that I know a whole lot about it, but all I know is that you put aluminium and you fix it with a screw onto a wall, the area around it is for sure going to corrode. For sure. Guaranteed. Okay? So what do you need to do? You need to insulate it. We all know about insulation. We all work with wires. Wires have an insulation so that even if you touch it, you don't get electrocuted. Similarly, you got to ensure that your frame is not anchored to the wall where the screw is touching the aluminium frame. Okay? And there is a solution which is called frame fastener, which I will explain in the next slide. Frame fasteners are freely available in Sri Lanka. They are sold by Demo, they are sold by Worth, they are sold by a company called Klimas, and there are other people also selling it. So they are freely available and they're not expensive. Of course, they are more expensive than a simple roll plug and a screw. That is for sure. A frame anchor would probably cost about maybe 70 to 80 rupees, whereas a roll plug will be like a few cents or few rupees, like 10 rupees or even less. Right? So be careful. This on the left hand side is the standard roll plug that everybody will understand and recognize. Used widely, you can just drill a hole, put this in thing, and then screw it. Okay, it works. But that's not the correct thing to do where aluminum is concerned. A frame anchor is one on the right hand side, and you can see that it's got a long plastic sheath. And then it's got a little kind of a ripple at the top where it sits against the aluminium and it prevents the screw from touching the aluminium. This is super important. Please don't use roll plugs for fixing aluminium to a wall. And also it must be told that the aluminium itself should be technically away from the wall using spacers, which I will come back to that again in the next few slides. But still, the powder coating and an anodizing is still okay. But when you drill a hole, you take away all protection. There is no powder coating there. There is no coating. It's raw aluminium. And you put a screw there, you're electrically conducting that aluminium to the structure. That causes corrosion. Okay? Sometimes this corrosion comes up through a different space, especially where the 4-bar hinges are, because they are actually stainless steel. Another common thing our guys do is when you put the glass onto the frame, it cannot touch the aluminium. Okay, so for that purpose, we have what is called glass cleats, which everybody can buy. It's available at TCI. But most people end up putting pieces of alucobond or cladding, because these are offcuts available in their workshop. They take a whole bag full of that. If you find anybody with a bag full of alucobond or cladding sheets, please throw it. Okay? Because what happens is, if you're using a coated glass, we'll say whether it is low E or solar control or any glass, how that glass works is by having a metallic coating on it. Okay? This metallic coating is not aluminium, it's something else. If that comes into contact with the aluminium, you will find discoloration and a rainbow effect. The most famous building where this happened is actually in front of Mayura Lane. You know that funny yellow colored mosaic. It was Satosa or some it's a corner building. Many years ago, and I think I noticed that all the colors of the rainbow on the glass. It is completely gone. Okay, so ensure that your glass is fully insulated, and these are actually very low cost, cheap products. Previously, contractors would use pieces of plywood, but we know how poor the plywood quality is. They don't use it now, but they find it very convenient to use a piece of alucobond, which they happily come and put it up. Okay, so having enlightened you all about all these facts about these windows falling off, and also by saying that we don't have regulations that covers all these aspects, these are Hong Kong regulations which you can actually download from the net. And the Building Regulation Authority, I don't know, in Singapore they call it the BCA, but I don't know what they call it there, but this is there, valid. Aluminium windows have become popular in new developments and as a replacement of steel windows in existing buildings. Recent incidences of failure of aluminium windows have aroused the safety concern as falling of a dislodged casement from a height can be catastrophic in densely populated areas. Building Construction Regulation 3 stipulates that materials used in any building work or street work shall be of suitable nature and quality for the purpose which they are used, adequately mixed or prepared and applied. Obviously, such requirements are applicable to aluminium windows to be installed in any buildings. This practice note specifies requirements on the design and installation of aluminium windows and the prevention of water seepage. Compliance with the design and installation requirements of aluminium windows described in para 3 to 7 of this PNAP will be accepted by the building authority as meeting the provision of the Building Construction Regulation 3. Any deviation from these requirements shall have separate substantiate for acceptance. So which means that the approval authority is looking into this in Hong Kong before approving. Okay, obviously we don't have the UDA looking into this. We have the UDA checking, whether you have a hole in the ground to collect rainwater, but we don't have anything like this. So let's go through it a little bit further. All structural members of a window section shall have minimum aluminium thickness of 2 millimeters, and the depth of the mullion section shall not be less than 38 millimeter. Particular attention shall be paid to the fixing details of the hinges. All hinges and fastening mechanisms adopted in the installation shall be able to withstand the positive and negative pressures due to the designed wind conditions when the window is closed. To ensure the strength and rigidity of a side-hung casement window as well as safety, occupants operate in the casements. The maximum width of a sash would be 700 millimeters. So that's a bit of a damper because 700 is actually a really small window, 700 millimeters. So some of you all may not be actually happy with that, but that's what the architects in Hong Kong will probably have to deal with. Or maybe they have to go and then explain and say that, look, we've taken adequate precautions. We can have a window which is more than 700 and there's a way of opening and closing, because obviously they're talking about if you have something longer than 700, you have a tendency of falling off because you've got to grab it. If it's a 1 meter, then you've got to put your body out and you can fall. Where 4-bar hinges are adopted, reference should be made to the guideline on fixing 4-bar hinges at Appendix B. So one can understand that there are very specific regulations operating in Hong Kong against falling windows or window safety. 4-bar hinges shall be manufactured from stainless steel with adjustable frictions too. All stainless steel bars of the hinge shall have a minimum thickness of 2.5 millimeters for better corrosion resistance. Stainless steel rivet screws shall be used for fixing hinges, and aluminium rivets shall not be used as they tend to corrode. At least 3 numbers of 4.8 millimeter diameter stainless steel rivets or 5 millimeter diameter stainless steel screws, these are not self-tapping screws, shall be used to fix each bottom and top bar of the hinge to the window frame and the openable sash. As stainless steel hinges and rivets and screws are used in aluminium window installation, due consideration and measures should be taken to prevent contact between dissimilar materials. So, all what I said is actually regulation in another country. It's not here. But you can actually, to some extent, be aware that such regulations exist, and you can check yourself whether your contractor is aware of it. If they are not, educate them and tell them that it's better to do it this way rather than doing it the normal way that they have been doing. So there is they go into much detail here. This whole lot is actually downloadable from the net. I don't want to waste your time going through all this text. But this is how it is. This is interesting. Okay, I need a pointer. Okay, you can see here in this drawing where they have identified an infill for the hinge to go and get screwed onto. You can see that the aluminium is very thin, but there is an infill here. And in this drawing here, you can see that part of it is thickened to the 4 millimeter or the minimum thickness required. But we don't get extrusions like that. It's very expensive because like you'll have to do that for the entire window. So other manufacturers have adopted different methods of fulfilling this requirement using a much more cost-effective system, which I will show you. Again, here you can see that the thickness of the aluminium here is not the wall thickness, but much thicker than that. And I've highlighted here again, just to make you understand. This is something that is used by most systems which are sold in Sri Lanka, maybe the brands Shuko or Sapa or anyone. But this part here is the infill, and it is locked into position of the aluminium frame. And the 4-bar hinge is screwed onto this. So you fulfill the 4 millimeter thickness screwed on requirement. This piece is locked onto the aluminium, and it is only running the required length of the 4-bar hinge. Okay. So what do our guys do actually? They import, saying it's a proprietary system, maybe from New Zealand, maybe from Dubai, maybe from somewhere else. They conveniently forget this. Because you can still fix the 4-bar hinge without this. They're so clever. They can do it. But it doesn't fulfill if you don't have the profile shape locking into the aluminium. That's the important part. So the advantage of this is the positive locking of sash and frame. The 4-bar hinge fixed by 5 millimeter threaded stainless steel screw and not rivet. And the pull-out strength is much higher than fixing by rivet or a self-tapping screw to wall or the sash of the frame. Again, this is a hinge that is available locally in the market. Again, you can see this piece here, and the way it is designed, it locks on to the aluminium and it can't get pulled out. It cannot get pulled out. So it's a positive locking mechanism that they use. This is very common in most European systems that are available here. If you ask King Long, they'll supply millions of these things. It's not expensive, but it's proper. Then again, the multi-point lock. So once again, it is classified as slightly more expensive than normal lock. You know, the normal lock people will use is like a batta, you know, they put it on the outside and then use 2 self-tapping screws, and the whole thing actually wobbles and shakes after some time. So multi-point lock by a reputed manufacturer is far better. And I must tell you that, like, you know, you can get expensive stuff in Sri Lanka. You can also get good, cheap Chinese products, especially because King Long is already here. They've got office in Rajagiri. I've been there many times. They got good stuff. So you can actually go there, you know, discuss with them. They're very obliging, and they will probably give you what is right for your project. I'm going to talk about painting and coating failure now. So we talk about powder coating, we talk about anodizing, and then we have peeling, flaking, orange peel, cracking, discoloration, oxidizing. And most of it is actually not limited to, but poor substrate and not prepared well, or inferior powder coat material, or an unqualified applicator, inadequate thickness for environment. For example, let's say that you're doing a project near the sea. Obviously, your powder coating thickness has to take care of that marine environment. So we don't have fluorocarbon paint in Sri Lanka at present. Jerry, we don't have, right? We don't have. We don't have because we don't have the processing facilities. Yeah, India has it, but there are certain projects where a foreign consultant will specify a fluorocarbon finish, but we don't have it in Sri Lanka. So we have, to counter that, Alumex will say that I'll give you a 25-year warranty powder coating system, which is accepted. Okay. Once the failure starts, there's no stopping. That's good news. Anyway, but you can remedy it by using the manufacturer's method of fixing it. They will give a system to say that, okay, you scrape it off, do whatever, but that the powder coating manufacturer has to give it to you, not Dilshan Fernando or somebody else. Jiri can. Okay. This is how it works. We have, somebody told, I think Professor told me, we have so many powder coating plants in Piliyandala. You did. Okay? Whether or not they're suitable, who knows? I can tell you, I had a powder coating plant of my own. Okay? And I can tell you, it's more simpler than spray painting. It is the easiest thing on earth. The system is that you charge the particles either positive or negative, and you shoot it through a gun. The piece that you want powder coated is the opposite of that charge. These charged particles just go and slam themselves on it. Okay? Then you fire it up and keep it for 15 minutes in an oven, which will heat it so that the powder will melt and then harden. You take it out, you have a beautiful finish. Believe me, I've done it. But the correct process requires sometimes 7 baths of treatment, rinsing, making sure that the substrate is well prepared, phosphating it, or making sure that the aluminium is given a light coat of anti-corrosive. All this happens in a proper factory. And how do you know a factory is proper? By asking, is your factory having any certification for anodizing or powder coating? Okay, this is only just one of the quality control organizations that are here in Sri Lanka and the Middle East. One is Colonod for anodizing, and the other one is Colcode. Obviously, if you need to have their certificate, you have to pay money to them. They come and inspect, and they say that, okay, you guys are doing the job to our expectation. So for us to have confidence, then we must ask, where is your certification? ISO is a management certification. It's not a quality certification. ISO is managing. This is something else. So you can ask for a large project, you got certification, come and show it to us. Here we are, leaking windows, pet subject of every single architect. You love it. I don't actually. In my 40 years of career, I have come across only a very few leaking windows, believe me. I sleep well at night when it rains. Whereas when we used to do contract, and other contractors, get about 100 calls, anna leak, make a leak, the timber floor has got spoiled, etc., etc., etc. And I know that where we have used an inferior product, that we had major issues. So I think the JET project in Navala, we have major issues of water leakage because proper procedures were not followed. And that's our fault. Don't quote me. Okay. So you can see here on your left a very common occurrence of dampness or seepage coming through the corner. And you will find it in most projects. If you have what is called a pocket window. Now this is a term that I use, a pocket window, where you have a blind wall or a surface wall and you have an opening in there and you have a window. The very first window that I installed was for architect Rukshan, Hemas Vattala. And we had enough problems of water leakage on that. I want to take it to a bad memory. So, how does this happen? It happens from many reasons. One is that the window has a joint in the corner and that joint is not properly siliconed and glued. Okay, so there's what is called thin viscosity silicon, which they have to use. They don't use it. Second is, our practice of civil work is that you do the sides first and the bottom is done much later. So there is a thermal crack, and there is a crack which you can't see because we have put putty and covered it with paint. But underneath the putty and the paint, you have a crack. a thermal crack. Then you have water coming all over the floor from the bottom of it. So let me tell you what, forgive me for this, lack of window designing to deal with rain. In the past, we had eaves, we had vehicles, we had verandas. Our windows were not subject to rain because we had timber windows and none of it leaked because rain never got to them. But now, due to modern constraints, we do have windows that are blasted with rain. Architectural detail not adequate, window joinery defects, gaskets not performing, no proper seal to the structural opening, no weather bead on the beams of it. I hope I got that thing right. It's the dripple edge, as we call it, in other words. No cover for the windows, no subframe, no sill slope. No sill slope is major in the list where these things happen and water comes in. I don't think I need to go through much on this one, but I'll show you a detail. It's far better if you design a reveal on the window ledge to take care of your window. It's far better. Okay, this is not an expensive thing. Any contractor will do it. You just need to have the detailed drawing to show where the window is and where you want the reveal. And you notice here that you never get the contractor to put a bolt on the bottom bar here. All our guys will happily go and put a bolt and then they'll fix the frame. That's where water goes in. Better practice is to have a small piece of L-angle, aluminium L, riveted here and bolted there. Usually you put this for the negative wind pressure in high-rise projects. Okay? But you don't actually put something in between here. Because most systems are designed where this is like a tank and water will just pass out through the weep holes. Okay? That's how it is. Some systems will also have like a gasket on both ends where when they tighten the bottom frame. Okay? So this is pretty important. On the side, again, it's better if you can't have a reveal, ask someone to fill the inside with expanding foam. Okay? There's a reason for this. When you have windows, when you have positive pressure here and rain and moisture here, it's the rain and the wind that pushes the water in. Not that it leaks. From the tiniest hole, water is pushed in. Having the expanding foam here will prevent that. It will not allow the wind to come in. So no wind, the water will not come in. Okay? These are not expensive stuff. Worth is having this expanding foam. There are so many people who have this expanding foam. If possible, on the outside gasket, if you can put a molded piece, these are of course not freely available. Some systems have it. But this is something that I used very successfully. Because A, I can't trust the civil contractor doing the proper job here. I can't even trust him doing a proper reveal here. Before the window is fixed, I get a waterproofing done, 300 millimeters up and right around. This is a super detail. It works, believe me. This has worked for me in many projects, and I don't have the headache if I put a reveal here or a subframe, and if I waterproof the outside edge. I use H or Finco. They actually come and put a mesh and they do the job. Again, these are not very expensive methods, but it will make sure that your sill will not leak. Okay, so we are at the end of this presentation. The summary outcome of the discussion is basically for all architects and consultants to analyze the project and note the required parameters. No need to have fancy windows if it's a single-story house covered by other buildings. There's not much wind load. And if you have an eave, if you have a veranda, then no need to go into all this stuff that I have said. But if it is like more than 4 stories, if it is exposed to the elements, and if it's an apartment project, you've got to deal with, if it is 20 apartments, you've got to deal with 20 housewives. Some complain all the time. Even if it doesn't leak, they'll come and complain. So in this apartment business, it is super important. If it is in doubt, speak to a facade specialist, as there's loads and loads of Indian guys here. You can speak to them. Then review the specification by the QS. Now this is super important. Most of the time it's a copy-paste job and no one has the time to go through the specifications because you're all are so busy with preparing the drawings and no one goes through the specifications and it is just given out. So take time and go through the specs for the windows if you do have the time, but make sure that at least a junior will go through and somebody actually checks to see whether certain areas are covered. Be self-informed. Check the joiner in your windows. When the contractor comes with a sample, ask him to dismantle it and see what is there. The best sample is a dismantled sample assembled in your presence. That's the best sample. Check the details for the window sill, waterproof if required. Check the origin of material and the quality certificates, especially with powder. There are loads and loads of inferior Chinese powder that is coming, which is outdated, which is being used. Okay, each powder has a date limit. There's a time limit by which you have to use it. You can't keep it forever. Okay, so check. Do not use materials which are without certification. Use an experienced fabricator. Check the fabricator's knowledge. Please use frame fasteners and no aluminium pop rivets. If at all, use SS. Coated glass must not touch the frame, must not use cladding pieces and insulators. For projects facing higher performance, the 4mm spacer is a must. Check the wall thickness of the aluminium when fixing hinges, must be 4mm. Sliding windows must have anti-lift accessory. It is there in every single proprietary system. If you buy all the accessories, the last accessory is 2 pieces at the top of the window, at the bottom of the window, which will lock the window into the groove. Okay, it is there. No one should be able to tell you that it is not there. If they are doing it, then they are not buying it or they are not included in their cost. And your windows will not fall off if you have this. If you remember, Singapore requires it, Hong Kong requires it. Use frame fastener and insulated the frame. Subframe or reveal in masonry if required. And basically, I think that's the last slide. So thank you very much, and I hope you enjoy those who've...
We'll be moving on to our next presentation for today. And the speaker head in this session is Mr. Gerald De Seram. And before I welcome him to the podium, I would like to do the honors by introducing him to you. Mr. Gerald was a CEO of Akzonobel Paints Lanka Private Limited until his retirement in May 2017. Previously, he was a CEO of CIC Paints Private Limited, where Gerald's contribution to the brand Dulux made sure it retained its market leadership position in Sri Lanka for many decades. Having worked in the paints and coatings industry for approximately 30 years, his in-depth knowledge of all aspects of the industry and proven business leadership capabilities are well known and respected. Gerald joined CIC Paints at its inception, and during his time at CIC, he worked his way through many of the major divisions of the company, handling a diverse range of portfolios ranging from agrochemicals to adhesives, paint binders, and other industrial raw materials. Consequently, he possesses considerable experience and insights into the commercial aspects in both B2B and B2C business. Following the merger of the British MNC ICI with Akzonobel of the Netherlands, Gerald initiated and led CIC Paints' own corporate rebranding from CIC Paints to its present identity, Akzonobel Paints Lanka Private Limited. Following his retirement, Gerald established his own business that involves the protection and decoration of built assets. This company, FPS Alpha Private Limited, was a specialized paints and coating company that offers supply, application, and coatings advisory services. However, a key differentiator of his business was the extensive experience he brought that enabled him to offer insights into the correct specification and application of coatings to projects for long-term protection and decoration of steel and masonry from the damaging effects of weather, water, corrosion, fire, and chemicals to the use of high-performance protective and decorative coatings. Gerald was educated at St. Thomas's College and then went to boarding school in England, where he attended Bridgeton College and later the University of London, from where he received his BSc honours in biology and geography. He also holds a postgraduate diploma in marketing from the Chartered Institute of Marketing in the UK. Please welcome Mr. Gerald De Seram to the podium with a round of applause.
Thank you very much for that lengthy introduction. Believe me, all of it is true. President of the Institute, members of the Institute, and a lot of old friends. Thank you very much for giving me this opportunity to be here and to make this presentation to you. I hope it will be useful and enjoyable. So, without much ado, I will be talking to you about coatings, but more specifically, the high-performance architectural coatings as opposed to decorative coatings, which all of you are familiar with, you know, the usual emulsions, enamels, things like that. Everybody knows. But I will specifically be talking to you about the high-performance architectural coatings. So, first question, what are coatings and what are paints? Paints are a type of coatings, basically. So a coating is anything that dries to form a homogeneous film. Okay? If you roll out a carpet or some sort of matting, that's not a coating. It has to be something that is applied which then dries to form this film with cross-linking that goes on. The term is used to describe films, coatings are used to describe films with higher performance and specialized functional outcomes as opposed to being merely decorative. So, coatings will give you performance, paints will generally give you aesthetics. So all your pentalites and weather shields and all of those would, in the jargon of the industry, be referred to as paints, while something that gives you more long-term protection, scuff resistance, all of those sorts of things are generally referred to as coatings. This is just the general industry jargon I'm going through. Now, in what we're going to talk about today, we are specifically looking at heavy-duty coatings, right? Which are very tough, give you long lifespans, and are generally used for protection more than the aesthetic side. It gives you protection from abrasion, corrosion, fire, chemicals, pollution. And today I will be talking specifically about these particular types of coatings which give long intervals between the painting cycle. So, where a normal emulsion could be expected to give a 5-year between one painting cycle and the next, some of these things can be lifetime, depending on the application and of course the cost. So what are the types of coatings that we have to think about? We have, as Dilshan was talking, powder coatings for your aluminiums and things like that. Then we have packaging coatings which are used on your beer cans and your Coke cans and stuff. And there are different types of packaging coatings. You have the coil coatings which go on your Alucobond type of product in a factory. marine, which goes on ships, aerospace, which goes on aircraft, powder, there's a repeat there, and of course protective coatings, which is my area of interest. So protective coatings can be divided up into 3 specific application categories. One is offshore, and there you're talking about oil rigs, gas facilities, drilling platforms, undersea pipelines. There are, believe it or not, paints or coatings that can be applied on undersea pipelines, which obviously can't be brought up to the surface to be painted, where the divers can go and paint it underwater. Right? So very, very highly technical products. You have onshore, including tidal zones where the structure may be submerged with water, seawater part of the time and exposed the rest of the time, which, as Dilshan was also saying, is one of the most corrosive conditions that you can have, this interplay between salt water and air. So onshore would be by the beach or within 2 to 3 kilometers of the beach. Those would be tall buildings like our hotels, shopping complexes and all that are built up, getting built nowadays. Port City would be one of those, if and when it starts. Bridges, estuary bridges, ports, port structures like gantry cranes, that kind of thing. And then the other one, which is again of interest to you all as architects, is the inshore buildings, which are again tall buildings, airports, rail systems. If this mass transport railway comes about, all those stations will need to be painted with long durability paints, because it costs a huge amount of money to stop everything and repaint. Once you apply it, you want to forget about it for about 10, 15 years. Plus, of course, the safety side of fire protection and things like that. Power plants, highways, and so forth. So, when we talk of performance coatings or protective coatings, there are 3 types. One is high-pack, which is high-performance architectural coatings. That is the one that is of most interest to you. High-pick are industrial coatings and would be used pretty much in a factory. And the other one is for industrial maintenance, which we won't get into that. Let's focus on high-pack only. Most high-performance architectural coating systems will include high-performance anti-corrosive primer, perhaps an intermediate or a barrier coat, depending on what specification is required in terms of what the environmental rating is or the durability rating is. And then, of course, you will need a top coat for color, for some aesthetic value, but also to assist in weathering, because most of the high-performance protective coatings that are used are epoxy coatings. And epoxies under the sun tend to chalk. So you need to protect the epoxy, which is giving the protection from the effects of the sun, using a polyurethane-based top coat. So whom do we in the industry talk to? Specifiers of projects, yourselves, architects, structural engineers, property owners, painters and fabricators, because some of these applications are quite specialized. You can't just pull a basune off the road and tell him, do this. He'll make a mess of it. And sometimes retailers, but not often. We've been through this, project focus areas. We've said tall buildings, corrosion protection for steel, fire protection for steel, bridges. We've been through this list. By the way, if I'm confusing anyone, please put your hand up and stop me. Okay? Okay, now we come to the nitty-gritty. We have spoken about specifications. Bear in mind that unlike in, say, the decorative paint industry, this is very much a thing with horses for courses. Where your building is located, how long you want the coating to last, what kind of stresses and strains is going to be subjected to, all matter in what specification we give. You can't just say, okay, put one primer of this and 2 top coats and the job is done. It may be, but most often, no, because there's something specific to the location and the requirements of that building. So, when we are asked for a specification, the first question we ask is, where is it? So, based on the location of the building, is it in, Orgodavatta, which is a highly industrialized, highly polluted, there's a lot of sulfur dioxide fumes in the atmosphere, as opposed to say something in Bandaravela. It's very different. So you get the classification of the environments, C1, 2, 3, 4, 5, I, which is for industrial, 5M for marine. So anything, say, for instance, on the Marine Drive would be a C5M. Okay? Somewhere in Maharagama might be a C3 or a C4 because there is some amount of atmospheric pollution there. But something, a hotel or a resort being built in Bandaravela would definitely be a C1, where the thickness and the type of material that is used will vary because there the environmental challenges are not as great as, say, by the sea here or in a very industrialized area. You also need to bear in mind that if you, say, for instance, get a sugar factory in Monoragala, okay, Monoragala itself is not polluted. It's quite okay. It would normally be a C2 perhaps, C2 or a 3. But the inside of the factory, where the processing is going on, can have acidic fumes by virtue of the process and the raw materials that are used. So then you need to specify something different there for that reason. So that's the first thing. So the first question you ask is, where is it? What's the durability rating? How long do you want this coating to last? Because there's a cost involved. So, if you have a low durability, if he says, look, 5 years is fine for me, then you go for a low durability system. Most people will go for a medium, that is around about 10 to 12 years. Okay? But some structures, by virtue of the accessibility for repainting or whatever, may want a longer lifespan, which can be anything over 15 years. Okay? Then, going back to again what Dilshan was saying, when it comes to the powder coatings, the same is true for any kind of steel painting, which is that preparation and priming is critical, but it's the most often ignored or understated part of the whole painting process. All right? It is about 70% of the job to get the preparation and the priming right. Preparation would mean setting up the substrate to receive the paint. It could be by pickling, sandblasting, any one of those methods to get the right type of surface to paint. So, priming, of course, is priming, using the right primer in the right quantity, in the right way. high performance coatings, by virtue of the fact that they're high performance, need high levels of specialized preparation in order to get, because these are not cheap coatings. You're talking, even the cheapest coating might be about 5,000, 6,000 rupees a liter. So you can't monkey around with this thing. You need, if you're putting a high performance coating like a zinc rich epoxy primer, which is again a very expensive primer, you need to sand or grit blast the steel to at least Swedish standard SA 2.5. Then with that, if you're doing that, you have to make sure that the mill scale, something that you, architect, was talking about yesterday, that mill scale has to come off, because otherwise after a short while it will flake and fall off with the paint. That can be either sandblasted off or allowed to corrode and then cleaned off, because it will corrode and fall off. Then when welding is done, any kind of hot work, welding, when the fabrication process is going on for whatever structure that is being built, steel structure, the weld seams need to be properly ground, because if you have spikes and lumps there, the coating where the spike is won't get adequate film thickness. It will be thinner, because all the paint will be at the bottom of the trough. And then the corrosion will start there and spread under the coating system. The other thing that a lot of people forget, and I think that you as architects should ensure that your contractors do, is the double coating of edges. So if you take an edge like this, if you just paint it, along these edges, because of the surface tension of the paint, tends to pull away from the edge to the middle. That means that that edge doesn't have the required film thickness. And this is something, again, that we have seen on the Marine Drive with the project that we did. The corrosion always starts along the edge or along the weld seam. So what we recommend is that you do a 1-inch strip along that edge separately of the primer, let it dry, then you put your 2 coats or whatever of primer, so that you get an adequate build along the edge. These are little details that most contractors won't bother with, So it's important that as architects, as specifiers, even engineers, should ensure that that is done. So as I said, priming is 70% of the job. If you get that part of it, the preparation and the priming right, the rest is just, good looks. The choice of primer is critical to the success of the system. Depending on what is the outcome you want in terms of longevity of the coating system, what is the location of the place. Then as I said here, the choice of primer is made based on the type of substrate. Remember that if a lot of people paint GI bars or GI pipes or GI cross sections, and what they do is they just put a normal paint on it, and lo and behold, in 6 months it will start to peel off. If you're painting any kind of non-ferrous metal like galvanized zinc or aluminium, you must etch it first. Otherwise, the paint won't stick onto it. The other thing is that if you paint it inadequately and there are pinholes, you get oxidization taking place there and lifting the paint off. Same thing happens with powder coatings as well. You need to have a special holding primer which you apply before you put your main anti-corrosive system on. Okay? If you're not painting ferrous metals, if it's non-ferrous, you have to do that. Ferrous metals are a little bit more straightforward. And the desired lifespan of the building, as I said, people will come and say, I want it for 20 years, but then are you prepared to pay for it? Because it's a big cost difference. The other important thing to be aware of is that when you are using high performance coatings like this, it is inevitably to get some kind of performance outcome out of it. You're not doing it purely to decorate the thing, right? And therefore, it is important that you get somebody, your supplier or whoever, to come in and check the film thickness properly between each stage of the painting. So you apply your first coat of primer, check the film thickness, because you need that. After that, your second coat, check the film thickness. Then your top coats, check the film thickness. So that you end up with the specified film thickness that you require for whatever outcome you're looking for. It's too late to wait till the end and then say, no, it's not enough. Because remember, you have to have the right film thickness of primer, and the primer needs to be in contact with the metal. So, you can't add on top coat and hope to get the same result. So, I wasn't initially, this is what I was going to talk about, performance coatings. It's short and sweet. I will obviously take questions of any type of coating, whatever you want. Even decorative is not a problem. But I had second thoughts, and I thought that I would use the time to go through fire protection, because that is a very, very specialized, and with the number of high-rise buildings that are coming up, and with all sorts of materials being specified and brought into the country and being used, I think it's important that we are aware of the risk of fire and the damage that it can do, and what we can do to actually protect against it. So if we go on to, we've done protective coatings, now I'm talking specifically about fire protection. Okay, just an overview. What needs protection? One is the people, most important, and the other is the asset, the building. Okay. Whatever coating you give won't stop the building being damaged or destroyed even. But what it will do is it will give people enough time before you get a collapse to get out of the place, and for the fire crews to come in and rescue. The asset, obviously, the more you can reduce the damage to it, the better, because you'll be able to salvage something. So there are two types of fire protection. One is the active fire protection, which would be sprinklers, those cylinders, but these need regular maintenance. They need people to actually use them and point them at the fire, and they can be prone to failure. Some valve may not work when it's needed. And you have what we call passive fire protection, which is where I come in, with the intumescent coatings. Now, when you talk of anything that is intumescent, it means that when it's burnt or heated, it puffs up. So that's what intumescence is. So once you coat it on your structural steel, it's always there, right? You don't have to worry about it after that. It means zero maintenance, no manual handling, and it can double as a corrosion protection as well, because generally these intumescent coatings are thick coatings, so they would form a barrier to vapor and salts and all coming in and attacking the metal. Now, having said that, as you were saying, Dilshan, a lot of these things are done cut and paste. And I find that a lot of specifications that are given for fire have overload of anti-corrosive protective measures built in, which are really an overkill, because the fire coating is giving anti-corrosion anyway. So why are you spending on zinc-rich epoxy primers and all that? It's completely unnecessary. I have seen like coating systems of more than a centimeter thick. Nothing is going to penetrate that. So you don't need all this. So be aware of that. So there are two types of fire. One is hydrocarbon, which would be, petroleum, World Trade Center, plane crashes in, fuel starts to burn, that's a hydrocarbon fire, okay? Cellulosic fires are more of what day-to-day fires where your wooden furniture will start to burn or your curtains will start to burn, or that kind of thing. Now, the difference between the two, now this is now again important, okay? Forget this Chartec, Intercha and all that I took from a previous presentation, that those are brand names, don't worry about them. But basically, hydrocarbon fires are much, much hotter and they reach that heat much faster than a regular fire, okay? Now, the thing to remember here is that steel that is used in buildings has a critical core temperature. Critical core temperature means once it hits that temperature, it starts to lose its structural integrity. It starts to wobble and will collapse, okay? Now, the critical core temperature for normal mild steel is around about 700 degrees centigrade, all right? These charts show, the top chart, the white one, is a hydrocarbon fire. That's how the temperature moves up in a hydrocarbon fire. You can see that in less than 5 minutes, it has, 2 to 3 minutes, it has reached 700 degrees. And then the steel structure is not safe anymore, okay? The other one, the pink line, is a cellulosic fire, where it will reach its critical core temperature of around about 700 degrees, maybe in 30-40 minutes, okay? But given the traffic problems we have in Sri Lanka, the fire brigade may only just about get there in that time, right? So you think about that. Now, how intumescent paint works is that this is, if you take this as an H bar, right? It's coated. When it gets, when it is on fire, or rather when the fire reaches that, the coating, which would be maybe 5-6 millimeters thick, puffs up like rigifoam, okay? It puffs up to totally envelop the steel. And then what happens is that the fire starts to burn the puffed up coating, and it forms a char layer which eventually protects the steel from the effects of the heat and of the fire itself. So that's basically how it works, okay? As I've said here, this charring is where it forms that carbon film, the black soot, provides an insulating barrier around the steel, and what it basically does is it delays that 3 to 4 minutes for a hydrocarbon fire to maybe an hour, 2 hours, before the metal will reach its critical core temperature. So the char provides a tough insulating layer. By the way, one of the best building materials for fire resistance is wood, because it chars. And particularly if it's a square profile, it's the wood. Wood is a much better thing at retaining the structure of a building than steel. The char layer delays and lengthens the time taken from the steel to reach its critical core temperature. So it's a delaying thing, okay? At some point, that steel is going to go down unless the fire is put out. So what this does is it delays the collapse of the building and gives time for the fire crews to come in, deal with the fire, rescue people, get people away from the building, all that stuff. Now, that critical core temperature of the steel depends on the composition of the steel, the grade of steel, the thickness of the steel. So it's not like you can just call up and say, what do you recommend? And how many square feet per liter, all that nonsense doesn't come into this calculation. It's a very complicated calculation, which frankly, we don't do here. We give it over to specialists in our parent regional headquarters. We give them the lengths and the profiles and the thicknesses of the steel. Then for each profile, they do a calculation and tell you, okay, this is the system we recommend. This is the quantity of paint you need. This is the thickness. And when it is done, they will, if they're going to give you a fire rating, they will want to come and see that it has been applied properly, because this is not something you can play games with. Lives are at stake. Okay, now these are just some of the buildings that my previous employer have applied their coatings on, including powder coatings, by the way. These, of course, the two buildings in Singapore. This, I think, is in Shanghai. So, these are the sorts of buildings there where we use these products. And they can be at, extreme temperatures. The one at the bottom is the British Antarctic Research Station. So, they are able to, depending on the system you use, and as I said, horses for courses, you can get very, very good, not only good looking, but good performing outcomes from using these products. That's it. Thank you.
Next is a very important segment of CPD2, and that is the panel discussion. This session comprises of a moderator, that is architect H Wijewardena, who is our past president of SLIA. The panelist, architect Professor architect Professor M. Lalith De Silva, who is also past president of SLIA, and our two eminent speakers of today. And at the end of the session, the forum will be open for questions and answers. Firstly, I would like to introduce a panelist to the session, Professor M. Lalith De Silva. Professor Lalith De Silva completed his Masters of Science in Architecture at the University of Moderator in 1983. In 1998, he further completed a postgraduate degree in construction management from James Cook University with the intention of gaining international experience working in Australia. He holds over 25 years of experience as an academic and a total of 39 years of experience as a professional, where he was able to work with many international and local design practices and consultants. Professor Lalith De Silva has served numerous positions in various professional bodies. His professional involvement includes Principal Architect, Proprietary of Habitat, Chartered Architects and Engineers Sri Lanka, Vice President of Organization of Professional Associations, Sri Lanka from 2007 to 2008, and the President of Sri Lanka Institute of Architects from March 2003 to February 2005. His richly diverse background and work ethics has made him one of the most sought-after architects in Sri Lanka. Professor Lalith De Silva is a luminous visionary in academia, planning, designing, and construction who has contributed vastly to leading design and research in architecture. I would like to humbly request the moderator of the session, along with the panelists and the speakers of today's event, Mr. Dilshan Fernando and Mr. Ferdinando. Why do I keep saying Fernando? and Mr. Gerald De Seram to come forward and take a seat to continue with the proceedings.
Segment. And aluminium is something that is widely used, and also we have many, many issues. So one thing that what the clients want is a window or a door, not aluminium. So there we should go into the proprietary system. You can go and buy. Do you think that without a proprietary system, that we can achieve that? You go and buy aluminium from one guy, glass from another guy, bearings from another guy. So that all put together, whether it will perform, who will guarantee that it will perform? So that is one aspect I just want to tell. And also, as Rukshan raised the question, the aluminium systems, good systems, I believe, has a draining system itself. So what happens is, what we do, we just overlook the draining system, and we cut holes and drill things and cut sliding things, and then eventually you will end up in a mess, leaking. And now if you see in having a window, now one question would ask, so if you want to have a 2000 by 2000 size window in a brickwork, so what is the size we keep? Whether we keep a 2000 by 2000 opening, or what is the size? And as I understand, you have to keep about 5 millimeters more from either side, so that we can keep the window with spacers right round, and then you seal it off from either side with silicone, with UV protective, and also with paintable silicone. Those are the things that we miss all the time. So do you think the Sri Lankan market has all that to cater for a good aluminium window to produce? And also we talk about the powder coating. Now, you said the powder coating about the powder coating. Now we have all the SLA standards and C+A, aluminium, all those things are there. But who checks these things? Now if you have a BOI project, or if you are going to import aluminium, all kinds of aluminium comes. No one is going to check, and there's no authority to check that. I mean, many buildings that we put up recently, you have this problem. They get down aluminium at a very, very cheaper rate. But then while we have all specifications here, but they come and fix it. But after some time you realize the problem. So what do you think, how we should control that? How now, I told you that if you go to Piliandala, there are so many places you do powder coating. You get aluminium and powder coat and fix. Now you don't know where it came from. So what sort of controls we should have to stop that? And also something that again coming into the market is the recycling. The recycling aluminium is coming in a big way. I think one part is already doing it, others are getting ready to do it. Now there's again the danger. Now this is happening in steel. Steel recycling, there's no control. How much used steel can be used to produce new steel? There's no sort of regulation. Similarly, do you think that when you recycle aluminium, there has to be regulations and there has to be a regulatory body to check? Otherwise, the ferrous content of aluminium will go up and eventually it will corrode. So coming back to the paint business, I would like you to emphasize more on painting steel. You get the blue steel. We think if you go to buy to market, you always go for a very nicely looking blue color steel. But I think you can explain what is blue color steel and why you should buy not blue color steel but a slightly corroded steel would be your choice when you go to buy steel. So I think that a lot of members will enlighten on that, because you have to remove that blue color to apply whatever your paint coating systems. So that is very important. And also you said about the thickness, which we always miss, the thickness of paint. You know, you get 40%, 60% discounts for paint. But what does that mean? That you are getting a lesser thickness, isn't it? So I would like to enlighten on that, on those matters. Then I think we will leave it to Professor Lalith to further elaborate on these matters.
Shall we let the two speakers
Yes.
answer your question?
Yeah, okay.
So, okay, I got bombed with about like a zillion questions. Okay, first of all, on the subject matter of the proprietary system, this concept of proprietary is where a design company will design a set of windows together with matching components to perform to a particular loadings and specifications, whether it is waterproofing, or we call it water penetration, air penetration, so on and so forth. So when it comes to proprietary system, the system should be also attached to the test standards. So you can't just say proprietary and then miss out to say that, okay, it should conform to BSE and this, or ASTM this, so on and so forth. It doesn't make sense. So the aluminium of a proprietary system, the shape of it and the thicknesses and the strengths, together with how they manage to have the glasses and the locks all together, is tested cohesively as one unit. So it is not that you buy the aluminium from supplier X, get the gasket from supplier B, get the glass from somebody else, get the adhesive dub coning or whatever it is from somebody else, and then say that this is proprietary. No, it's got to be tested together, and most responsible suppliers and brands will have their own test certificates. So what we do in the industry is that we say, okay, fine, you get the aluminium and the entire list as specified in their documentation, and prove it to say that, okay, you're going to use these components. That's the only way you can check. So the sample board is brought in, and you got to check to make sure that the glazing gaskets won't come from TCI, and then something won't come from Asian Hardware, something will come from some aluminium company. It cannot be mix and match if you're expecting quality. It's like, we'll say you're paying money for it, you're buying a Merc or you're buying a Toyota. You're not expecting the Toyota to have, let's say, a different car engine and different seats. You expect the whole thing to be as one responsible design output from the manufacturer. So that's to do with the proprietary. The second question is that, do we need proprietary in Sri Lanka? I believe that we've got to move towards it. That there is no point saying that, like, let's go for proprietary. I mean, I believe in proprietary. I say proprietary, but economics of scale don't make it worthwhile to go for proprietary if I am going to promote to a client. But you've got to be careful how you produce your windows and engineer your windows. So you can be safe by saying, okay, let's go proprietary. But if you are going non-proprietary, be safe. So it's not to say that, like, for every project you must go proprietary. But somewhere down the line, Sri Lanka will end up having their own proprietary. Then we can all say that, okay, forget about this and let's go proprietary. But at this moment, if you go proprietary, we have to import a lot of stuff, and then the cost goes up. So you have to be mindful and juggle this around. If it is a hotel project or a highly prestigious project, yes, proprietary. If it is a one-off house or somebody and the windows are not that great and they're not getting wet, I think you can manage with some good choice of material. The second or the third question is all about quality control and who actually manages the quality control. We know that we have all the specifications, but who checks it? In most international projects, there is a guy who will check every single sentence in the tender specification against the submitters. There is. I've been through it. If it is a JICA project or if it is like an American project which came after the tsunami, they go to every little line item. They are professional. So if you put a document to say that you have all this specification in the document, the onus is on either the architect or the project manager to ensure that every little sentence is ticked off. That the paint is certified or the paint specification requirement is, we'll say 60 to 70 micron. Who certifies it? Architect cannot guarantee that the aluminum will come with it, but at least you should have a color calendar or a certificate or a statement by the supplier saying that we are going to give this. Because if something goes wrong, at least you are safe. You have ensured that there is a responsible party who has given you assurances. With reference to recycled aluminium, looking at it in a different way, right? We all want a greener earth. So we all want to recycle aluminium and everything else. But in recycling aluminium, it has to be done in such a way that it will not deteriorate as the other aluminium, the ingots that come to this country. I think there was a presentation by Alumix, which is doing a recycling project of a high quality. They are doing it now, and that is mainly for export because European countries will pay top dollar for recycled aluminium without getting the bauxite out from an African region. So recycled aluminium has its merit, but for architectural aluminium, usually recycled aluminium is not used, at least in Sri Lanka. We don't know what aluminium comes from China, because all we know is that China has a massive stock of aluminium engines which are recycled, aluminium rims. You know that half the world is Chinese, so they got lots of stuff that is getting recycled. Whether that filters down to Sri Lanka, we don't know. But I have heard that there is a scheme to have an SLS certification for aluminium coming to Sri Lanka, especially architectural aluminium. When that happens, yes. But until that happens, you're at the mercy of somebody who imports it, who will give you either good aluminium or bad aluminium. Have I missed anything? Deck out.
Water.
Water penetration and drainage. Oh yeah. I won't mention this name, but one of the most high profile projects in Sri Lanka, in the city of Colombo, the windows that they have installed are so poor in drainage that the people who paid top dollar are facing discoloration of their floors, and it's not only that, but the rollers that they have used are corroded and they're sagging and they cannot close the windows. And this is within possibly a year and a half. The contractor is missing. Okay, we don't want to know names, but this is what can happen when foreign contractors come to Sri Lanka. They all know we're a third world country. Do a job, go away, collect the money, and then leave utter total rubbish for Sri Lanka to deal with. So these poor customers who have bought at extremely high rate of per square foot cost are now saddled with it. So in terms of water drainage, I actually didn't want to burden you all with that technicality. The bottom line is very simple. I think we all learned in grade 5 chemistry or physics, pressure pushes water up. Okay, and we all know about the mercury gauge, the Chi gauge. Okay, so we all know by heart that 33 feet of water is the maximum that you can suck without it falling down, creating a vacuum. So we all know all about that. So aluminium profiles at the bottom should have sufficient lip at the back to prevent, let's say, air pressure of 600 pascals pushing water in. I'm telling this to you because I've tested windows in my lab, and a thinner section at the bottom will give you a lesser rating in water penetration. You can have every single gasket that you want, but it will not help. So you need to have the amount of water that is equal to the pressure of gravity into that water to prevent it from getting pushed into the inside of it. It's a very simple physical calculation. The second part is what we call equalization of pressure. Windows are designed for water to drip down the glass into the sashes, into the bottom rail, and get drained out through gravity by creating an equal pressure on the outside environmental as well as somewhere in between the window. So we know that if you have a massive pressure outside, let's say like 1000 kilopascals or 1000 kPa, or 3 to 4 kPa, inside pressure is not so much, but the difference of pressure pushes the water in. So if you have the equal pressure, the water will drain. So these are all part and parcel of drainage systems. Our guys will just put it together, they won't cut the water slot, they will not have the drainage taken care of, and you have leaking windows.
Okay, so DH, first part of your question was about the blue color steel. That is what we would normally refer to as mill scale. In the foundry where the steel is extruded and produced, you get what's called mill scale, which is like a very flat, very smooth layer on the surface of the steel profile, whatever it is, H iron or C channel or whatever. Now, that corrodes very fast and it also flakes off. It's not an integral part of the steel. Okay? So that is why DH is absolutely right. You let it corrode and then it will fall off of its own nature. However, if you haven't got time for it, okay, sandblasting or shot blasting will do two things. One is it will take the corrosion, whatever corrosion there is, off. It will take the mill scale off, and it will create little pock marks, provide a key for your primer coating to go onto and hold on to. So that is part of the specialized preparation of steel that I was alluding to when I was making my presentation. And that is absolutely essential that you get that right. Because otherwise, you will get a suboptimal result on your very expensive coating system. Then when it comes to film thickness, I think I will tell a story that DH and I were involved in a very small project on Marine Drive. Okay? Now, when the project was built, it's all steel structures with glass and all that sort of thing. When the project was built, the suppliers of the coating system had come, looked at it. They had produced a document very nicely done with pictures of people holding film thickness gauge quite extensively. It had started to rust along the edges, as I was explaining during my presentation, and along weld seams. But even in the HIN section, the flat parts had started to rust from place to place within just 6 months. So DH called me in. He was consulting the owner. The owner had called him to give some advice on what to do about this. He called me in, and when we went and checked, this 280 plus micron film thickness at some places was just 17, 15, 25, completely inadequate for that environment. So it is, we had to grind off the rusty parts. we used, obviously it's a built thing, you can't go sandblasting it once it's constructed. So we had to use specific primers, what we call surface tolerant primers, which are tolerant of hand clean metal without the need for sandblasting. We had to use primers with very high anti-corrosive pigmentation. We used micaceous iron oxide, where the iron oxide flakes actually come, and when the paint dries, it settles one on top of the other like that, prevents vapor penetration better than any other pigment. So that's what I'm saying, that whoever comes and gives the specification needs to know what they're talking about, because you can't just do a generic recommendation for this kind of job. It is absolutely important that you get the right product used in the right way, then you will get your 10-year thing. Now, one more thing that I want to stress. Even though we talk about a paint coating system with a life cycle of say 10 years, where you paint it today, you will next expect to repaint it in 10 years' time. But you must make sure that it is checked from time to time in that 10 years, and wherever there are spots of corrosion coming, that you just touch up those areas. The coating system itself is in good condition, but maintenance is important. No coating system will give you 10, 15, 20 years where you can just close your eyes to it, unless it's very, very expensive systems which are inaccessible, in places that are inaccessible. Like for instance, the undersea pipelines that I'm talking about, certain parts of aircraft, once they paint it, they don't look at it till the aircraft is trashed, because it's not possible, right? So, but those are unique coatings which are very, very expensive. For the sort of stuff that we are involved in, you need to do some kind of maintenance work along the way, but you will not have to do the full repainting for whatever time that is stipulated.
Thank you. Shall we move on to Professor Lalith, who is for the discussion? If you have any questions, you can write it down. You can take one or two.
I'm pleased to congratulate both speakers for giving us excellent two presentations, which took us along our memory lane and refreshing our memories and learning some new things. My comment about Dilshan's presentation. All this is known factors about the stainless steel screws, and instead of L sections, you put locking devices into profiles and so on. So that is why the architect should thoroughly involve in specification writing without delegating the task of writing specification to quantity survey or some engineers or anything, because the design is the person who knows the design best, the requirement of performance best. So therefore the architect should write, if you are getting it written by somebody else, should get involved thoroughly in writing specification. So I think in that way we can either go to a proprietary system or non-proprietary system, where you can assemble and get the things done to the user needs. So I suggest, all architects should learn from this presentation that we should be thoroughly involved and know where it can go wrong. Especially, you mentioned about the fasteners, and fasteners also has to be locked into the profile, right? And there are a lot of profiles which can increase the weight of the aluminium section. Now in the procurement, what we price in a BOQ is the square meter area of windows, and you evaluate also the tender by rate per square meters. That can mislead, where they can provide lower profiles or weaker profiles and give the square meter coverage, right? And that can give a cheaper window but non-open window.
So what you say is you must have the specifications right.
Specification, right?
Yeah.
And also evaluate by weight of aluminium, not by the square meter, by weight of aluminium. So your evaluation of the aluminium windows is by weight of aluminium, weight of steel, and the accessories.
How about paint presenters? Anything that you want to tell? Yeah.
Yeah.
They say they are running
Yeah,
out of time.
let me tell something
Yes.
about ask about. Now you mentioned about say silicon sealant. Silicon sealant. You can answer after I. Silicon sealant is the filling material, different types of silicon. I have used other types of sealant. It's not a silicon because it is not a waterproof material. This can be decayed due to infrared, and silicon can be deteriorated and can give leaks. So there are different materials like thioflex, grade thioflex, things like that you must be knowing. And this is not available in Sri Lanka. I don't know whether it is now available. I have wrote down this kind of material for Singapore. I have the experience of fixing a curtain window in an auditorium in Goa Medical Faculty. Those days, 50 feet one curtain window was a big task, and the contractor was from Switzerland, right? And they did one mirror aluminium curtain wall in the auditorium facade, right? So I suggest that should be covered by specifically writing and procurement process. So my question to you is, now where we have gone wrong, either by using the recycled aluminium or by not having the proper practice by professionals.
I think to answer very quickly, because we're running out of time, I believe. Architectural detailing, proper detail is an absolute must. I'm telling this to everybody here because I started my career as a draftsman. And we use an AJ metric handbook for all the detail. Detailing is now a bit of a forgotten art. So do the reveal right, 90% of your problems are sorted. In terms of silicon, there is a lot in the market. Those days we used to rely on dark corning, but there are new products in the market, and a lot of people want paintable silicon, so on and so forth. I'm sorry, but I'm not having enough adequate knowledge myself to answer that question about different types of silicon. But I do know that in the market there are different types, other than silicon. There are water-based stuff for outside and inside. So proper careful study by yourself would be okay. It's not a super important part, but it is important. But the assembly of the window is the more important part. And unfortunately, I can't talk too much about silicon because I don't know.
Right.
Yeah.
Yeah, thank you. Just to add to your silicon,
Yeah.
what happens if you all use general silicon?
That's wrong.
There are so many types of silicon, which are structural silicon, silicon that can be painted on, silicon that are resistant to UV. So the thing is to use the right silicon. How about Gerald's presentation? Shall we quickly
I know.
relieve him?
I know the Sri Lankan construction industry is now converting from concrete to steel. You can see many steel buildings coming. And one of the most important things in steel buildings are not only decorative painting, as she correctly mentioned, the coating, the protective coating in marine environment and like less environmental hazard environment. But now you said that the fire coatings like luminescent paint can be a fire retardant and a protector. Right? Can we do decorative painting on that coating? How how smooth it is? Is it like textured or smooth?
It will have a mild texture.
Mild texture.
It will have a mild texture, but nothing that is, like of concrete or something. It will be less than that.
Can you do a finishing coating on that and to paint?
Yeah.
Right.
Thank you, Lalith. Since we can give about 2 questions from the audience. Anybody wants to raise any questions, we must give a chance to the audience. If you have anything to ask from these 2 gentlemen, we very eagerly waiting to answer any type of question as you told at the beginning. Anyone? Oh, right. That means, yeah, there's one.
Thank you for 2 of you speakers for this presentation. Basically, I have one question each for 2 of you. First, Dilshan, about these aluminium sections. Now, mostly you are importing, that you very correctly said, without no proper quality or even the profile sections. Now, in other parts of the world, you have to address certain climate conditions like overheating and all that. Hence, we have this very complicated compartmentations in the section itself. Do you really need that particular section to suit our climate? Or can the cost be reduced by using some sort of appropriate sections in this part of the world? And the other question to Gerald is just to find out, most of these applications are very toxic in terms of application, in time of application. Can you just say something about it? How
Yeah.
sort of protect ourselves?
Sorry, to answer your question, this aluminium actually design is a pure structural exercise. So the structure, the design of the extrusion and the way it performs is based on a structural calculation against the torsion or the deflection where the limits are given. So whether it has so many hollows or not or whatever it is, it's the designers who take it forward for interaction with other angles or whatever it is. So it's a structural decision rather than an architectural decision. I hope I answered your question. It's a pure structural decision.
That in terms of the stability and the strength of it.
Yes.
Are more in terms of like for cold climates, you sort of have this.
No. So that is something else. That is what we call thermal break systems. We don't need thermal break systems here in Sri Lanka. We actually, because our temperature differences are not that extreme. We are looking at like maybe 40 degrees to about 22 degrees, whereas other countries will have minus 20 going up to 40. So we don't generally use thermal break systems. That's the question.
So that means can we use a simpler section in this one?
Normally in Sri Lanka we use non-thermal sections as a rule. We don't use thermal break at all in Sri Lanka because we don't manufacture it here. If it is imported, yes, but we don't need it.
Okay. Is there a question for
For the toxicity.
Yeah.
You asked about the toxicity of the paint that is being used. Basically, all of these performance coatings, these high performance coatings, are solvent based. There are some water based as well. So when it's solvent based, there are fumes that come off, and in some of the hardener that you add to the paint, there are things called isocyanates in there. But in the case of epoxies, no isocyanates are used. Isocyanates are generally used in polyurethane type, 2-pack polyurethane paints. Now, that too, not on all polyurethane, only some. But given if you're working in an open area where there's a good flow of air, generally there is no hazard to the applicator, right? But if you're working in a very enclosed area where the ventilation is poor, then definitely the applicator should wear a cartridge type mask to prevent the inhalation of those fumes. After that, once the paint has been applied, given that these are two-pack paints which are very, very hard, you can't scratch it off or it doesn't come off on your hand. So in terms of danger to people living in the building or something, it's not really an issue.
Okay, then since we are running out of time, shall we conclude this session?
Can I?
Yeah.
Now, in the process of application of coatings and painting, what we have been doing in the industry is we continuously monitor the painted yard with one of our engineers or somebody, and during the painting process we take the wet thickness of the paint, and when it is completed and dried, we take the dry thickness. So there's a specification for wet thickness and for dry thickness to ensure the quality of painting, and it is continuously covering the surface. So that is what we do in the industry. So I think that way, I think you agree the
Absolutely.
quality control.
Okay.
I mean, as I said earlier, generally, depending on the coating and the way it's composed, chemistry of it, the wet thickness of let us say 100 microns wet film will translate to maybe a 70 micron dry film. But ultimately what you want is to have a certain dry film thickness on the steel. So even if you don't, taking the wet film thickness is good in that you avoid having to correct mistakes later. But even if you don't do that, at every stage, as I said during the presentation, at every stage, say you have two coats of primer, one intermediate coat and one top coat, okay? There are 4 coats. At each of those 4 stages, somebody should come with a dry film thickness gauge and test, not in just one place or the other, test the edges, test the hard to reach places. So somebody competent needs to come and do a multiple check and get a feel as to whether that layer of paint has been properly put, adequately put. If not, you correct it then rather than later.
So, thank you very much, Dilshan and Gerald, and also Lalith. We have concluded this, and we'll hand over the mic to the presenter. Thank you.
I would like to request the panelists to remain on stage. And I would like to invite the president of the SLIA, Prof, the senior vice president of the SLIA, Dilshan, the chairman of the PAB, and the chairman of the CPD, Architect Dharmi, to come forward to present the tokens of appreciation to our lovely speakers, panelists, and the moderator. Next, Mr. Gerald De Seram. Our panelist, Architect Professor M. Lalith Silva. And last but never the least, the moderator of this session, Architect H Wijewardena. Thank you to the presentation party, and I would like to humbly request you all to take your respective seats.
Don't worry, I won't take much time. On behalf of Sri Lanka Institute of Architects, I would like to extend my heartfelt gratitude to our esteemed speakers today, Mr. Dilshan Fernando, Managing Director, Eurometallic Private Limited, Mr. Gerald De Seram, former CEO of Akzonobel in Sri Lanka, and our moderator, past President Archt H Wijewardena, and the panelist, past President Archt Prof. Silva. Thank you very much for your valuable contribution, sir. Also, I would like to thank the President, Architect Prof. and the Council of the SLIA, and Chairman, Professional Affairs Board, Architect Mr. and members of the Professional Affairs Board. Special thanks to Chairperson CPD Committee, Architect and members of the CPD Committee. And our sponsor, Street Makers Private Limited, thank you for coming forward and helping this LIA. And our company, Architect Vilakshi Ravindra, I hope I pronounce your name correctly. And we must mention SLI staff and our caterers today, GA caterers, and music band, Mr. Hiruka Madhuvanta and his team. Finally, I would like to thank all of you present today to helping us to make this event a great success. Thank you.
And now it would be the business card draw, a bit more and you obligate your dinner. I would like to call upon the President of SLIA, and a representative from our sponsor company to please come forward to maybe choose the winners for today. Architect Bhatia, I can read out the phone number also though. This can't be happening. Give a round of applause, he got a pillow. Now the second place. I don't mind the bed. Is this a real name?
Yeah.
I'm sorry, I couldn't read the letters. I read it completely different. Architect Ganga Gamage. And the first place, Architect Kapila Priyantha.